that you do the disk method. The disk method means that volume is equal to the integral of pi r squared. Usually you use the disk method if it's around the x-axis and the sample rectangle touches the axis of revolution for the entire region. Your other option is something called the washer method. For the washer method, volume is equal to pi integral big R squared minus little r squared. These are the two that I would use if it's revolved around the x-axis or anything parallel to the x-axis. If it's revolved around the y-axis or anything parallel to the y-axis, I'll usually use a method called the shell method, in which case the volume is equal to pi, or 2 pi that is, 2 pi RH. You may notice that all of these are two-dimensional areas of either circles, such as pi r squared, or two-dimensional circles, such as a washer. When I say a washer, I'm talking about a washer like this, a mechanical washer that has a big radius and a small radius. And the shell method is 2 pi RH is a lateral surface area of a cylindrical shell, hence the name shell method. So if I was to do, suppose I was to do the volume of a solid known as, let's say, y equals the square root of x, y equals 0, which is the x-axis, and some x bounds, such as x equals 9. Now I know what the square root of x looks like. It's half of a parabola. I'm going from 0 to 9. And y equals 0 is the x-axis. It should enclose a region such as this. If I revolve this region, I'd like to revolve this about the x-axis, such as this. I'm going to draw my sample rectangle. So I'll draw a sample rectangle here. I'd like to revolve this rectangle about the x-axis, forming a disk. Notice the length of the rectangle is the radius of the disk. Now, because the rectangle touches the axis of revolution over the entire region, you're going to use the disk method. The disk method is the integral of pi r squared. So I need to figure out what the radius of this disk is. If you follow my advice, everything will be in terms of x, so we're going to use dx. My bounds on the x-axis are 0 to 9. And the radius of this disk would be the height of this rectangle. In this case, it is y. Y happens to be the square root of x, so I'll fill that in. Now this is the setup. Whenever I give a quiz, I'll give half credit for the setup, half credit for the solution. If you square the square root of x, you just get x. If I integrate it, I have to raise it to the 1 higher and divide by the 1 higher. And I'm integrating it from 0 to 9. I'll keep the constant out front. I'm sorry, 0, x equals 9, okay. So if I put in a 9, 9 squared is 81 over 2. Minus, put in 0, 0 squared, 0 over 2 is 0. Hence, the volume of this solid of revolution is 81 pi over 2. That would be the volume if it's revolved around the x-axis. If it's revolved around the x-axis, I usually use either the disk or the washer method. Because this rectangle touches the axis of revolution everywhere in this shaded region, therefore I would use the disk. if the rectangle did not touch the axis of revolution, I would use the washer method. I'll do an example of that now. Okay, suppose I have y equals the square root of x, y equals x squared. You can find where they meet by setting them equal to each other. X squared is equal to the square root of x. To get rid of the square root, I'm going to square both sides. So I get x to the fourth equals x, squaring both sides. Subtract the x over is x to the fourth minus x equals 0. Factoring an x out is x times x to the third minus 1. Now there's two values that make this equal 0. Either x equals 0 or x equals 1. So when I have this x squared, that's a parabola opening upward. And square root of x is a half of a parabola. And I believe they meet at 0 and 1, enclosing this shaded region. Now when I revolve this about the x-axis, because I'd like to revolve this enclosed region, and I'll always tell you what it's revolved about the x-axis. Now if I draw my rectangle here, notice the rectangle does not touch the axis of revolution. So that means you're going to use something called the washer method. The washer method is pi big R squared minus little r squared. Now notice the radius. Big radius comes from the axis of revolution to the furthest point on the rectangle. Notice vertical lengths are usually y. The question is, what is this y for the big radius? Which curve is it hitting up here? So that would be the square root of x. So the big y, or the big radius, is y, but it's going to be the square root of x. So when I fill it in, I have the square root of x, and this is squared via the formula. Your small radius goes from the axis of revolution to the closest point on the rectangle. That's also a vertical, and that's also y for your small radius. But what is your small radius? Which y is this one? I believe in this case it's x squared. So this would be x squared squared, again, because of the formula. Now where to where on the x-axis, where do they meet, is at 0 and 1. So I'm going to integrate this from 0 to 1. Again, I'll box it in because that's my setup. When you square the square root of x, you get x. You square x squared, power to power you multiply, is x to the fourth. Now if I'm going to integrate this, I'm going to have x to the 2 over 2. You have to raise it to the 1 higher. After I do that, there's no more integral here. So I'll go ahead and get rid of my integral. Because after you integrate, the integral symbol and the differential both go away. So I have pi times raise the 1 higher, divide by the 1 higher, raise the 1 higher, divide by the 1 higher. And then I plug in from 0 to 1. I'll plug in my upper bound, which gives me 1/2 minus 1/5. Minus, putting in my lower bound, I think I end up with 0 minus 0. Because I have to get a common denominator to combine these fractions between 2 and 5, the common denominator would be 10. So I have times 5 over 5 would be 5/10 minus 1/5. 2 over 2 would make that into 2/10. So that makes my volume equal 3 pi over 10. This is an example of the washer method. I hope this helps.